This video is going to continue our discussion of the multivariate analysis of variance, except now we're going to be including covariates. So it's a Mancova. And so we're going to go to Analyze, General Linear Model, Multivariate. And we're going to select these variables. Our income 2 and education 2 go into the dependent variables box. The fixed factors are job satisfaction and sex. And now we're going to add our covariate of age. So it's exactly like the previous analysis, but now we're adding the covariate. And then we're going to go to Model. We're going to choose Custom. Now we're going to choose all three of these individually to go over here. And then you'll notice down here we have this interaction variable, which was created by holding down the Control key, selecting all three of those, and then moving it over to this spot. So that's all set. Then we go to the options, and our preliminary analysis, we just want to do a homogeneity test. So we'll click that and continue, and we'll examine the results. And what we see is the box's test of equality of covariance matrices is not significant, which means we've met the assumption. And if we come down to look at the effect of the interaction, we see that it is not significant. So the interaction effect of those variables will not be examined. So now we're going to continue our analysis. We're going to go to Analyze, same as before, Analyze General Linear Model. Click on Multivariate. We're going to keep those variables in place. Hopefully they're still there for you. We're going to click on Model. We're going to switch it from Custom to Full Factorial. We'll click Continue. Then under Options, we're going to do as we did before in previous analyses, which is move our variables over to the display means for. And now we're also going to select descriptive statistics and estimates of effect size, and we'll keep the homogeneity test selected. We'll click Continue, click OK, and we'll generate the results of the analysis. And for our interpretation, we can come down to the means. We'll see here that now, controlling for age, that males work more than females, and that income. Males make slightly more than females, controlling for age. In fact, that might be a wider gap before we were controlling for age, as I recall. For education, yes, males work slightly more than females, and now remember we're also controlling for the effects of age, because that was our covariate. If we look at job satisfaction, we see the very satisfied make more money, controlling for age, and also have more education. Although the very dissatisfied also have a high level of education once we control for age. Now if we scroll to the multivariate tests box, we can see the effects of the variables, and we see that age, if we look at the Wilks lambda, is significant. So it is having an effect on our combined dependent variables, and it's a small effect. And with job satisfaction, we also have a significant small effect. And with sex, Wilks lambda, again significant, but a rather small effect going on there. And as before, as we noted, the interaction of job satisfaction and sex, not significant. And if we scroll to the test of between subject effects, our ANOVA, we can look at the effect of sex on income and see that it is significant and not significant with regard to education. If we look at job satisfaction, similar story. We have a significant effect on income, but not on education. Once again, the effect sizes, by looking at the partial eta square, rather small. And that will conclude our analysis multivariate analysis of variance with covariance. Thank you.